welcome to the Talking Crop podcast. I'm Kathryn Seebruck, commercial agriculture educator with University of Illinois Extension, serving Daviess-Stephenson and Winnebago counties. Talking Crop is a seasonal crop production podcast with episodes occurring every other week during the growing season between May and September. In each episode, I bring on a guest speaker to discuss topics related to their areas of expertise, as well as to talk about any projects that they might be working on. In today's episode, I'm joined by Dr. Nicholas Seiter, who's the Extension Field Crops Entomologist for the Department of Crop Sciences at the University of Illinois. Nick and I talked about the corn rootworm monitoring program and alfalfa weevil reports. Please be sure to review and evaluate the Talking Crop podcast at the link in the video description. And this is also where you can find any relevant links for each episode. So for example, in today's episode, you can find the link to Nick's bulletin article that we discuss, as well as the link to the Corn Rootworm Adult Monitoring Network webpage. Please keep in mind that it just takes a couple of minutes to complete the evaluation and review of the podcast. And again, this gives me all the information that I need to help make the podcast a better listening experience for you, to change things that you might not care for, or to keep things that you do. The next episode of Talking Crop will release on Wednesday, July 24th. And without further ado, please enjoy this episode of Talking Crop, titled Talking Corn Rootworm Monitoring with Dr. Nicholas Seiter. So Nick, welcome to the Talking Crop podcast, and thank you for being here today and taking the time out to have this conversation.
Oh, sure. Thank you for having me.
Absolutely. So we'll just jump right into it. I recently looked over your most bulletin article and post about corn rootworm beetle emergence. And in your post, you write about how rootworm beetles are starting to emerge throughout Illinois, and they will continue to emerge throughout Illinois throughout the next couple of weeks. And so I first want to start out with, using this to kind of reflect on this growing season, particularly late winter, early spring, because a lot of the questions that I get from people kind of in a lot of different facets, even outside of agriculture, is, are insects going to be a big issue this year because we didn't have a severe winter and we had kind of that mild early spring. So what do you answer to people when they ask that question? I'm sure you get that a lot as well.
I do get that one a lot, and I usually answer it, it depends, because it kind of does,
Sure, yeah.
It's an evasive answer on my part. But when we look at rootworm in particular, corn rootworms are pretty well adapted to our climate, meaning that we don't typically have a lot of overwintering mortality in Illinois with that particular species. The further north you go, the more of that you can potentially see. And so if you get up into like Minnesota and the Dakotas, for instance, if they have a really cold winter, which is a different thing from our really cold winters, right?
Sure.
If they have a really cold winter, they might not see very many western corn rootworms, and that'll sort of flip their balance to northern corn rootworm a little bit. For us, there can be some winter mortality, but it's pretty limited. And the bigger effects for us, as far as how big of a rootworm year it's going to be, one is, how big it was last year. So how many beetles we had on a field-to-field basis last year. And that's what we're starting to see right now is, right, we'll start to see what's our potential injury next year going to be over these next probably 4 or 5 weeks. They have a fairly long period of time that they're active. The other thing that helps to regulate it in terms of weather is soil moisture, and especially soil moisture in like late May when those eggs are first hatching. And what happens is if we see saturated soils while those eggs are hatching, and I'm talking especially like if they're standing water, so a lot of water, that really knocks the rootworm population down considerably. And in fact, if it happens at the right time, it can take it down to about 0. Wet weather in the spring doesn't really matter. If it's still in the egg stage, they can swim, I guess. Like it doesn't hurt them when they're that wet in the egg stage. It's once they've hatched, and especially right when they hatch, that they're the most vulnerable to that. We probably didn't have a lot of that this year. We had, it's starting to get kind of dry throughout a lot of the state now. When those eggs were hatching, soil moisture was pretty adequate for the most part for most of us. Depending on where you're at, there's obviously a lot of local variability in that. I don't know if the timing was quite right, but some of the flooded areas in Minnesota and Iowa, that might actually put a hit on the rootworm population. It's not going to cheer anybody up because they're dealing with much bigger problems than insects. But
Right.
When you get that kind of a scenario over a wide area, it can really knock it back. The other thing that affects our populations is how well our trait packages are performing. And over the last 5-6 years, give or take, as we've started to see more and more injury to pyramided BT traits in particular, we've started to see that population creep up, especially in northern Illinois. And there's no doubt those traits are the primary reason that our populations are not what they were 20 years ago, right? Or even 15 years ago, before the introduction of pyramided BT traits in particular. Those really knocked those populations much lower than they have been historically. But they're starting to creep back up in some areas. And I would say, for the most part, even in areas where rootworm has been a real problem over the last 5 years in Illinois, we probably still don't have the population density that we used to.
Okay.
But it's becoming more of an issue, and a fairly difficult issue to manage if we have a population that's highly resistant to pyramided BT traits.
Right. So going back to the timing of this emergence, I think your article discusses how you're already starting to see some in Urbana, so in central Illinois. I'm way up in the very northwest corner of the state, and obviously that's, central Illinois is very different from that, and central is also very different from southern Illinois. So what is kind of the, I guess, breakout of that emergence? So in terms of like roughly how many weeks difference will there kind of be between those kind of more general regions of the state?
I would guess, and I'm going to make a spitball guess that's not based on, like, I didn't consult the degree day calculator or anything, but I'd
Sure.
say maybe a week and a half,
Okay.
something like that. You'll probably start seeing them soon if you haven't already. I know I got a report from our colleague Russ up in Grundy County
Hmm.
last week, and he was finding some emergence there. So it's moving along, and if you don't have them coming out already in northwestern Illinois, you will quite soon.
Hmm. Sure. And so, with this emergence, the main premise of your article in the bulletin was about the monitoring program. So, can you talk a little bit about that and describe, I guess, the purpose of it and how an individual could get involved and why they might want to get involved as well?
Oh yeah, absolutely, and that's a project. So my colleagues, Aaron Hodgson and Ashley Dean over at Iowa State, started this maybe 3 years ago now. 3 or 4 years. It's hard for me to keep track how long we've been doing it.
Hmm.
But basically, we're trying to get people throughout the whole north central region. So not just Illinois, though you get locally relevant results if you put traps out, but
Sure.
Illinois, Iowa, Minnesota, Wisconsin, Indiana, Michigan, Canada. There's traps out in Ontario and maybe some other provinces as well. And so they've really got quite a large network. And we're trying to keep track of a couple of things. One is simply population fluctuations from year to year. So just looking at, okay, 2024, what are the hot spots in rootworm emergence? Are they different from the hot spots last year? Do we have things changing? Are they expanding? Are they contracting? Where are we seeing higher populations of these beetles? And the other thing that we're looking at, and really, I think one of the things that sort of drove Aaron and Ashley to start this network is the species breakdown. So for the last, I'd say since about 2020, 2019 maybe, we've started to see more northern corn rootworm in the system in, I mean, not southern areas, but southern for corn rootworm, right? So like we've started to
Hmm.
see more northern corn rootworm in Illinois and in Iowa, where for many years that insect was almost completely gone. Like we barely saw them. We didn't really think about them. I know actually, when I first got here, thinking 2018, 2019, talked about northern corn rootworm at a meeting up in Freeport, so not far, I think, from where you're at. And
Hmm.
one of the folks in the audience said, "Oh, we don't even think about that one anymore. I kind of forgot it existed." They've started to pick up over the last several years. We've started to see more of those, and so by using these traps, one of the things we want to keep track of is sort of the patterns of that particular insect and where they are showing up, and if they're showing up, in combination with Western corn rootworm, or if they're sort of displacing Westerns in some fields, or what that really looks like on a regional level. And so our trapping program, it really is kind of focused on the regional level. We don't necessarily, because it takes a lot of traps in one particular field, we're not focused on getting a perfect picture of what's happening in any one individual field, because that takes a lot of traps. Maybe more than we can ask
Hmm.
people to do for free in a volunteer program. But we want to look at those regional patterns. So what we ask our cooperators to do is set out a line of 4 traps in a field, and a lot of our cooperators choose to monitor cornfields, like continuous cornfields, but
Hmm.
in Illinois, historically, we've had the rotation resistant variant of Western corn rootworm that you would trap in soybean, where we're
Hmm.
worried about egg laying in soybean as a threat to first year corn from the following year. So it's up to you as a cooperator which of those you want to do, or you can do both. Generally, in the past, we've had plenty of traps to where, if you ask for 4 fields, like enough traps to do 4 fields, I'll send you enough traps to do 4 fields. If you have 6 fields, probably send enough to do 6 fields too. We haven't really exhausted our supply of traps in
Hmm.
years past. But we have been able to get, between 10 and 20 cooperators in Illinois. And that's really helpful regionally, for kind of monitoring these patterns. So if you want to participate in this, you can shoot me an email. I think you'll probably link that in the podcast, but it's nseiter@illinois.edu. Send me an email, put rootworm trapping, ideally rootworm trapping 2024, but something like that in the subject line. And
Hmm.
give me your shipping address and the number of fields that you would like to do, and we will send you traps and we'll send you a protocol. Um, and then we can upload the data for you, or we'll send you a link where you can upload the data yourselves if you would prefer to do it that way. Um, yeah, and they'll be visible at a site that you can get to, which is another one I'll share with you, but it's rootwormipm.org. And that'll take you to kind of a landing page, and from there you can go to our regional monitoring network, and you can see the map in real time. Not everybody uploads their data at the same time, so I would rely more on the annual reports that my colleagues put together, where they wait until all the data have come in for the season. Bear in mind, with this data, you're not necessarily, you wouldn't be using this to like time an insecticide for beetles, for instance. You're using this information to make decisions next year.
Sure.
So that report will come out sometime in the fall, and you can look at that and see not just what's going on in Illinois, but what's going on in surrounding states. In Canada, if you're curious about that, we actually end up covering a pretty wide geographical area with this network.
Nice. Yeah. And so if someone did want to be involved and they get sent the traps and they set them up, you talked about sending, them either inputting the data themselves or sending it to you. So what does that entail? How often do they have to go out and check the traps, and what data, I guess, are they specifically taking when they go out there?
Yeah, great question. So you do this for 4 weeks. So you'll set your traps out, and then you'll go out each week. You'll replace the traps. You could count them in the field if you want. You could count the beetles in the field, or what I like to do is these traps are such you can fold them up. You mark on it which trap it was, bring it back into the shop or somewhere where it's cool, where you can spend a little bit of time looking at it,
Hmm.
and you count the number of Western corn rootworm beetles and northern corn rootworm beetles. We provide a little, like an identification aid as part of the protocol. So some pictures of what these different species look like if you're not familiar with them. Once you've done it, they're pretty easy to distinguish. So the Western corn rootworms are yellow and black. The northern corn rootworms are green. The harder thing probably is to distinguish some of the you get some other beetles on there that if you're not being careful look similar.
Right.
But if you're sending us the data, you can just keep track of it on the protocol that we sent you. You can keep track of it in an Excel sheet, however it works for you. And then just when you're done with the trapping after 4 weeks, send the data to me along with some information about the field, where it was located, and I'll get it entered. And you can send that with precise like GPS coordinates if you want. If you don't want to share that, that's all right. If you can give us the approximate area, I'll set it up to where the point is like the nearest town or something
Hmm.
like that. And so we can still get the data up there, still have them relevant to the area without identifying your particular field if you don't want that particular field identified. Um, Yeah, or if you're entering them yourselves, you can actually enter them from the field. You can enter them from wherever with a phone. There's a platform for doing that. It's relatively simple to do. There's instructions for it on the website. Setting the field up for the first time is a little bit, I wouldn't say it's hard, but it's not intuitive. So you do have to kind of
Hmm.
follow those instructions and make sure you're dotting all your T's and crossing all your I's that way. But it'll guide you through how to do that on the website. And some people prefer to do that. I think they find that it's less likely that they'll forget to send the data or forget to send it in if they enter it themselves in the field. But it's really sort of at your discretion as a cooperator.
Right. Yeah. That sounds pretty simple. Like you said, once it gets set up, but pretty simple to just get out there and do some nice and easy counts. And I know earlier you said that part of the kind of reason behind this monitoring is to record the species specifically and kind of look at where they're being distributed. I think in that article, you also talked about resistance. So it can help you kind of figure out if there's any resistance events occurring. Can you describe how you monitor that? So I'm assuming then you're potentially getting information of, what traits are being planted in those fields. Is that the case? So that you understand, I guess, what control measures have been implemented.
Yeah, there's a couple of things we can do, and you can use the adult counts themselves as an indication of resistance. For instance, if you put them in a field that has a particular trait package, and you start to see high beetle populations early in the cycle, that could be an indication, usually an early indication, that that trait package is starting to fail. Now, on our end, on the regional monitoring, we don't necessarily collect the exact trait package. We've got a
Okay,
place to list if it's traded or not traded. Um,
gotcha.
for our purposes, that information I don't think is really listed in the report. But for your information as a cooperator, if you get those fields out there during early emergence and see those beetles coming out of that trait, we usually see elevated beetle populations before we see high levels of pruning, like as a trait is starting to fail. So usually those beetles are kind of the first indication. The one thing you got to watch out for if you're doing this scouting is the later it gets in the season, the more likely those beetles are to sort of leave the field they emerged from behind and start moving around. And so the later you get in the season, the more likely it is that those beetles might have come in from somewhere else, especially if you have later planted corn. So we find that later planted corn if it's tasseling after everything else, it becomes kind of a magnet for those remaining beetles, right? That's
Sure.
actually how we draw them in to our research plots as we plant corn really late
Okay.
the year before. And we'll mix pumpkins in and that kind of thing, but that's neither here nor there. The other thing we're interested in with monitoring, so to get more of a precise look at that, every year we collect beetle populations around the state, and we actually bring those back to our lab. And my colleague Joe Spencer in the Natural History Survey, he'll collect the eggs, and next year when those eggs hatch, he will assay them on these different BT technologies to see how well they survive. So we do more of a direct bioassay in the lab, and that gets us a more definite answer. And the bad news for us as researchers is that's a lot more work, right? That's a lot of
Mm-hmm.
work to do all that. The good news for you as a cooperator is you don't have to do any of that. All you have to do is send me that same email, except instead of I want traps, it's hey Nick, I've got a field with some beetles in Ogle County. Can you come up and get it? And if we
Mm-hmm.
can get up there in time and collect those beetles, we'll bring them back into the lab and take care of the rest of it. And we'll even next year, when we find out the answer, we'll let you know how they're doing, how resistant your local population is. The other thing we're hoping to look at with those bioassays going forward. So in northern corn rootworm, you have a trait called extended diapause, where some of those eggs will hatch after 1 year, which is kind of the standard rootworm life cycle. As those eggs are laid in the summer, they hatch the following year, and that's when you see damage. Well, with northern corn rootworm, populations of that insect have evolved to where some of the eggs hatch in 1 year, but some of the eggs hatch after 2 years or 3 years or 4 years.
Mm-hmm.
And you can imagine why they would do that. So those larvae survive on corn. They don't really survive very well on anything else, and they don't survive on soybeans, for instance, at all. So if you're in an environment where there's crop rotation, uh, and especially if you're in an environment where there's mostly crop rotation and you want to survive as a rootworm beetle, you've got to find a way to deal with that. And extended diapause is the way that northern corn rootworm has found to deal with that.
Mm-hmm.
The disadvantage of it on our side is that's a difficult trait to really get a picture of exactly what's going on, right? Because you have these beetles coming out for multiple years. Um, so the question becomes, okay, we had a high northern corn rootworm population in this field last year. How long do we need to follow that? And so when we collect northern corn rootworm eggs this summer, in addition to looking at BT resistance, we're going to look at how many of them hatch after year one. And we're going to try to look at how many of them hatch after year two as well to get an up-to-date measurement of extended diapause, which hasn't been looked at in Illinois really for many years, for several decades now, in part because we haven't had that many northern corn rootworms
Mm-hmm.
like we once did.
Yeah, that's really interesting. A couple of points you made. I think it's great that this monitoring program, it benefits both you as researchers, but also the cooperator. It's a chance for them to get out and scout in timely manner, and that information is helpful for them. And then, it gives them an idea, I think, as well. Like you said, with the resistance, if you do have a resistance event occurring, you will let them know. Um, and so I have a little bit of a conceptual question for you. You're talking about, the diapause, and it sounds like you're measuring that, you know, scientifically, research speaking, like phenotypically by seeing how many are hatching and when. Has there been any research on any like the genetic link to that at all?
I think there's been some research on it, but we don't have a marker. There's
Sure.
been some research on the inheritance of it.
Okay.
So we have a number of colleagues looking at like corn rootworm genomics, western and northern corn rootworm genomics, and trying to find molecular markers for resistance to BT and also for traits like extended diapause. I don't think anybody's quite nailed that down just yet. And I'm not, you know a lot more about that side of it, I think, than I do. I'm not a genomics person. I'm not a molecular biologist at all. My understanding from the people who do that kind of work is that the genomes for Western and Northern corn rootworm are hard. Like
Yeah.
they're on the tricky scale of genomes, compared to,
Hmm.
I think, some other insects are pretty simple. And I don't even know enough about it to give you an intelligent answer of like why they're hard. I know it's big. Like I know for an insect
Right.
genome, it's large, and I think it has a lot of like duplication and that kind of thing. I don't know exactly, but that's been the answer I've got. I'm sure it was dumbed down to where I could understand it, and it was basically, yeah, the genome's really complex. We don't know any of it.
Yeah, I mean, simple answers are better, right? It would be nice though, like
Definitely
you
for
said,
me,
you have that bioassay for the resistance. It would be nice to have some sort of
yeah.
assay or genetic assay that you can utilize for diapause instead of, I think it's a little bit maybe rougher of an estimate when you're just doing counts of hatches and such.
Yes, and the other big disadvantage of doing it phenotypically, the way that we have to do it, is we get an answer about the same time that the farmer gets an answer, right?
Mm-hmm.
So we have to wait for those insects to go through their diapause over the winter and then test them next year.
Yeah.
So we can get those bioassays going like in May or June. I think Joe starts doing them in May. And we can know before you see the pruning in the field. We can't know before you've bought your seed. And so
Right.
it's not something that we can do fast enough to get you an answer that you can act on. Whereas
Hmm.
if we had a molecular marker, yeah, then we could collect beetles, grind them up, test their DNA, and have an answer very quickly. And it could be an answer that you could act on as a pest
Yes.
manager. Our time scale, the way things are right now, unfortunately, is a little bit slow for that. So you can act on it in subsequent years, but
Hmm.
you can't act on it immediately. And that's something we would love to change, but I certainly do not have the skill set for that. Fortunately, we've got some people in the community that do, and I think that's one of the things that they're looking at. And yeah, every year when we meet, I kind of ask them how close they are, and every year it's, well, it wasn't this year. We didn't get it this year.
Yeah.
Next year.
Yeah, that would be a great change going forward for sure. Going back to the resistance, so you talked about how you can screen for that, and if you determine that you are seeing resistance in a population, you'll let the grower know. So, what then is the next step for the grower if they do have confirmed resistance in their populations?
Yeah, there are a couple of things that you can do. The nature of BT traits is such that rotating to a different trait package generally isn't going to help you a lot with that. And the reason for that is there's a lot of overlap, not just in mode of action, but in the actual proteins that we use. So essentially, we have 4 BT proteins, 2 modes of action. 3 of them share a mode of action, and the other one is distinct. We also have now RNA interference. So a third mode of action. So that's a completely distinct mode of action, but it's deployed in combination with BT proteins, for a number of reasons. One, it's a little slower acting than a BT protein, which is a very fast kill, which is actually one of the reasons BT was, you know, has been so popular, is it kills the insect very fast. So if a
Hmm.
susceptible insect feeds on it, it's dead within hours, certainly within a day. Um, so that's part of it. Rotating modes of action isn't going to help us a lot. Rotating your crop is the best thing that you can do from a strict resistance management standpoint. And the reason for that, so even if you have like a rotation resistant rootworm population, so you have either Western corn rootworms where they're laying their eggs in soybean in addition to corn, or you have Northern corn rootworms that are going through extended diapause. Any of those eggs that hatch into soybean are dead. Like if they hatch, they're in soybean, there's no food, they die within hours.
Hmm.
They don't live very long if they're not able to find a corn plant right away. And so even if you're not reliably protecting next year's crop by planting soybean, you are reducing the population in an area, because every soybean acre that followed corn is going to have eggs in it that are going to hatch, that are going to die.
Hmm.
Right. So that's the best thing that you can do, probably the most reliable thing. And it's no coincidence, like our worst problem fields for BT resistance are almost exclusively like long-term continuous cornfields.
Sure.
And especially when you get past like 3 years of corn. So you start getting 4 year, 5 year, 6 year, 10 year, 20 year
Hmm.
cornfield. Uh, that's where we tend to see our worst resistance problems. So breaking up that cycle is the single best thing you can do. If you rotate in terms of control, actually rotating to an insecticide is your next best option in terms of resistance management. The tricky thing about that is that our most effective insecticides have never been as effective as a functioning BT trait, especially a functioning pyramided BT trait, in
Hmm.
preventing root pruning, and then especially in preventing adult emergence. So we don't really reduce adult populations very effectively with a soil insecticide. And the reason for that is the same reason that we don't see a lot of resistance to soil insecticides, at least the soil insecticides that we use today. It's because you don't treat that entire root mass when you put an insecticide down. It's kind of a mosaic, especially in the center of the root mass where most of that material is. And so on every root mass, if it's treated with an insecticide, you're going to keep enough roots with that insecticide to prevent economic loss, but you're also going to have this large root area that's essentially untreated, where you have beetles feeding and emerging. And so you get more pruning even on an effective soil insecticide than you do on an effective BT trait. You also get more beetle emergence.
Hmm.
And that's the reason that, like, when we started using pyramided BT traits, we reduced the population on an area wide basis in a way that we never did with insecticides.
Yeah, sure. Yeah, those BT traits are very, very effective. And I know people really do see the benefit of not having to use insecticides, at least not quite
Yes.
as much. So yeah,
Yep.
huge benefit. So it's great that this program is monitoring that resistance so that we can make sure that, that technology remains effective so that we don't have to, use any alternative methods like again, insecticides. Um, so shifting gears a little bit, I know when, I asked you to join me today, you talked a little bit about how you wanted to mention alfalfa weevil. I know reading some of your crop reports, you've mentioned them once or twice. And so I wondered, were the reports that you got, were they increased this year? I've gotten a couple questions about alfalfa weevil myself up in this part of the world. So yeah, what was the status of that this year?
Yeah, it was there were a lot of alfalfa weevils this year. It seemed like it was in most alfalfa fields statewide. I mean, you could at least find them. You didn't have treatable levels in every field, but they were pretty widespread. And in terms of like the number of calls in that, I got more questions about alfalfa weevil this year than I have in the 6 previous years in Illinois. So it was pretty widespread. They got going a little bit earlier in the spring, and with that insect, it really helps it to build up in numbers, but it also, the earlier it starts, the more injury they're able to do prior to that first cutting, which
Hmm.
traditionally is when, um, usually alfalfa weevil for us in Illinois is a first cutting pest primarily. But yeah, it was a big year for those. The other thing, we did get some reports of control failures, and lambda-cyhalothrin, that's a pyrethroid insecticide that probably the most widely used pyrethroid insecticide in Illinois. Um, in alfalfa in particular, it's one of only a small handful that are available. And of the ones that are available, it's by far the easiest to find, like the easiest to
Sure.
buy. The supply is the biggest. So we use a lot of it. In the western United States, over the last several years, they've documented resistance to lambda-ci. We haven't actually documented it in Illinois, but we have received a number of control failures, notices of control failures over the last few years. That's always a little bit complicated too, because you always wonder if the timing was right on that, and all that kind of thing. And in a lot of cases, if we're not scouting alfalfa, we sort of find the weevils after they've already done their thing in many
Sure.
cases. A lot of times for us, the timing is such that we find them, and the best thing to do if you can do an early cutting is just to do an early cutting, to salvage that cutting and regroup and start again. And usually that the alfalfa weevil population doesn't take that very well. Usually that helps to knock them back.
hmm So, if an individual was to do an early cutting, would there be any other method of control or prevention that they have to utilize for the rest of that year then, or is that it?
Usually not. Usually not. In a particularly bad year like this, they can do some injury to the second cutting as well. I didn't get a lot of reports of injury to the second cutting this year, so I'm hopeful that that's because it didn't happen.
Yeah.
um, but so usually it's a first cutting type pest for us. There are some other insecticides available as well, indoxacarb in particular. They tend to be more expensive. The other insecticides we have that have alfalfa weevil activity, they also tend to be a little harder to find. And if it's a material that you weren't planning on using at the beginning of the year, it can be a material that's difficult to sort of scramble and find. It's not
hmm
it's not always, you can't always just call up the distributor and get it the way you can with lambda-ci or with like bifenthrin, which is not labeled in alfalfa or some of the others.
Sure. And then you talked about how it seemed as though their emergence, or at least the damage they caused, was a little bit early this year. Is that just due to, that mild winter? So like going forward, for example, if we have another mild winter, would you, recommend that folks get out and scout a little bit earlier? Um,
Yeah,
or
absolutely.
is okay, yeah.
Yeah, absolutely. You nailed it. That's exactly what happens. They become active early. They tend to be the first insect pest that I hear about in a particular year. So of course, you have perennial stands of alfalfa, so
Right.
it's out there.
Yeah.
And they become active really when the temperature starts to exceed like 45, 50 degrees. They'll start to get going. I usually get an email from Robert Belm down in Southern Illinois, down kind of around the St. Louis area.
hmm
Oh, usually like mid-April, that they've started to see some alfalfa weevil injury. And like everything else, probably 3 weeks later, where you're at, it is where you'll start to see them.
Yep.
It just takes y'all a little longer to accumulate those heat units. So they just, yeah, kind of work their way from south to north in the state, because of that development.
Okay.
But
Yeah.
yeah, they're active early for sure. And so when you
hmm
have these unusually warm, mild winters, early springs, they start to do their thing sooner.
Yeah, for sure. Um, all right, and then I have another, I guess, conceptual question for you. So this is more like broader, bigger picture, not necessarily about a certain insect pest or what have you, but we talk about when it comes to integrated pest management, we talk about economic thresholds. So making sure that you are getting out and scouting to make sure that you're not applying for, let's say, an insecticide before you need to. But at the same time, there's also this concept of, preventive application so that, you don't have a problem in the first place. So how do you, I guess, strike a balance between those two? Because you could argue that if you're waiting for that economic threshold, that it could be, potentially too late, so to speak. And of course, I know when we talked earlier at the very beginning, sometimes it depends on what species we're talking about and what crop we're talking about. But do you have any like kind of general, discussion about that?
Yeah, absolutely. Absolutely. And I think it really comes down to a couple of criteria. One is how likely the insect pest or complex of pests you are targeting is to show up. And two, how effective that preventative application is relative to a more targeted application that occurs once the insect has been found.
Hmm.
And I'll give you maybe a couple of contrasting examples here. So if you think about something like a seed corn maggot, if you're familiar with that insect.
Hmm.
So that's an early season pest. It feeds on the developing seed, right? And there's not really a rescue application for it.
Okay.
So once it occurs, there's not a lot that you can do. And so if you're in a situation where you have a high likelihood of seed corn maggot, and the situations that would give you that likelihood are I'm planting early, I have a field with heavy organic matter, either naturally because you have like a bog soil or something like that, or unnaturally because you're a livestock operation and you're putting manure down, or you're tilling in green manure. Those would be the most likely things to get seed corn maggot going, especially when it's incorporated in.
Hmm.
In cases like that, a preventative application like a seed treatment is likely to be the most effective. When you look at an insect like black cutworm, in that case, the situation that makes that insect most likely is high annual weed pressure, and especially high annual weed pressure that you failed to control. The seed treatments are fairly poor as a standalone control for that insect. In general, a rescue application, if it's timed right, is extremely effective. So if you get a pyrethroid insecticide, on top of that, they have to be in the field already.
Hmm.
Uh, you'll kill them, and you'll kill them very effectively, usually without much heartburn, as long as you get a sufficient water volume. And of course, at that time of year, it's not so hard to get sufficient water volume. If you use your
Sure.
herbicide sprayer, uh, yeah, you're probably going to be able to get fairly effective control. And so in that case, we really push a scout and treat, type approach to that because it's very possible. And the one thing those two have in common is it's actually pretty easy to predict which fields are going to have a problem. So there's
Hmm.
a risk factor, a series of risk factors that you can use to determine that you're going to be controlling those. One, a preventative approach is going to be more effective. One, a reactive approach is going to be very effective. When we get later on in the season, what I guess always concerns me, especially about like the sort of the R3 insecticide applications, that go out at R3 just because. Well, most of those, that residual material is going to last for about 5 to 7 days. And there's some variability. I mean, if you use like a premix product, you'll get some additional time, but it's not like when you think about a residual herbicide, giving you hopefully several weeks of control. We don't have a lot of insecticides that do that.
Hmm.
So if we put out a preventative insecticide at R3, we don't have something in the field now, but we think we might later. Well, if later is not the next 5 to 7 days, we haven't done ourselves really any good. We've also kind of given ourselves a false sense of security because we think, well, I used an insecticide, I should be good.
Hmm.
And then we find several weeks down the road, maybe we actually have an infestation. And that insecticide we put out at R3 didn't do a thing. So how effective it is, you have to take that into consideration. Kind of the overlying the driving factor for us in Illinois is that we are blessed with a relatively low frequency of economically damaging insect pest infestations.
Mm-hmm.
So it's pretty uncommon for us to get an economic infestation of a pest. And that's not to say we don't see pests in pretty much every field. I mean, we see some pests in virtually every corn or soybean field you would ever walk, right? You're going to see some, but it's fairly rare for us to exceed those economic thresholds, those levels where we're actually losing money because of the impact to yield that these insects have. And that's ultimately why, for most pests, most situations, we recommend a scout and treat approach. It's not just because it's more effective for certain species. Again, there's species where it's more effective. There's species where a preventative approach is more effective.
Mm-hmm.
But for most of the insects that we talk about, our economic infestations here are relatively rare. And so if you're treating every field to maybe hope that you'll get the right timing on the 5% of fields that actually need an application, or I should say could benefit from an application, it's probably not the most effective use of those inputs.
Sure. So yeah, it sounds like, when it comes down to it, obviously scouting, as we know, was the backbone of your IPM strategy. But beyond that, not just scouting, but understanding your pests and understanding the most effective control measures for them so that you have a good idea of whether that preventive or that reactive method of control is going to be your most effective option.
Yeah, that's right. And just understanding what your risk factors are, understanding that, like, if you're a conventional tillage operation and you got good winter annual weed control this year, you probably don't need to think about black cutworm, even if the
Mm-hmm.
moth flights are high. You're unlikely to see that insect in that situation. If you're in a no-till operation and you don't use manure, you didn't put green manure in there or something, you're probably not going to struggle with seed corn maggot.
Mm-hmm.
Just understanding what pests you're likely to see based on field history, based on your practices, based on where you're at in the state. That goes a long way to where now you're not scouting for everything in every field all the time.
Mm-hmm.
You're doing a targeted scouting approach for those insects that are most likely to be a problem for you in Ogle County or Madison County, wherever you might be.
Mm-hmm. Yeah, absolutely. Well, Nick, that is all I have for you. So again, thank you so much for taking the time to join me today. I really enjoyed our conversation.
Oh, no problem. Thank you for having me.